Are you ready to be a scientist like George Ohm and do an experiment to derive Ohm's law? This is our voltage supply. We can change the potential difference supplied by it by turning this knob. The voltage supply is connected using this red wire to this instrument called an ammeter. The ammeter is used to measure electric current, and the ammeter is connected using this wire to this black box. The black box contains a nichrome wire in it through which current can pass through. This is usually called the resistor. To measure the potential difference across the wire, we will use this instrument called the voltmeter. If you draw the circuit diagram for our setup, it will look something like this. For our experiment, we are going to change the potential difference across the wire. Now I'm going to switch on the voltage supply. But as you can see, the knob is at 0 volts. So no voltage is being supplied. The voltmeter shows 0 volts and the ammeter also reads 0 ampere. And this is our first data point, 0 volts and 0 ampere. Now let's increase the voltage to 2 volts. As you can see, the potential difference across the wire is now 1.2 volts. And note that this ammeter is marked in milliampere. The reading in the ammeter is 30 milliamperes, which is 0.03 ampere. Note that the wire does not get the full 2 volts from the voltage supply. The potential difference across the wire is 1.2 volts. Let's add it to the table of observations. Now let's increase the voltage to 4 volts. Now the potential difference across the wire as measured by the voltmeter is 3.6 volts. And the current in the wire as measured by the ammeter is 100 milliamperes, which is 0.1 ampere. Let's add it to the table of observations. Now let's increase the voltage to 6 volts. As you can see, the potential difference across the wire is now 6 volts. And the current in the wire is 180 milliamperes, which is 0.18 ampere. Let's fill it in our table. Now let's increase the voltage to 8 volts. The potential difference across the wire is 8.4 volts, as shown by the voltmeter. But this is a bit strange. How is the potential difference higher than 8 volts, which the voltage supply is giving us? I think it's probably because the voltage supply is a bit faulty. It's giving us a voltage higher than 8 volts. But we are interested only in the potential difference across the wire. So for our experiment, it doesn't matter. And let's check the reading in the ammeter. It shows 240 milliamperes. So the current in the wire is 0.24 ampere. Let's put it in our table. We will plot a current versus potential difference graph. As you can see, the graph is approximately a straight line passing through the origin. And this is exactly what Ohm concluded from his experiment. So Ohm's law states at a constant temperature, the current flowing through a conductor is directly proportional to the potential difference applied across the ends of the conductor.